Hello, how y'all doing today? My name is Bernie Thompson, and today we're here to take a look at this 2011 Honda Pilot. This little Honda has a problem where it stalls intermittently. Apparently when it gets hot, it starts to stall. Now it will stall just sitting here, so we won't even have to drive it, so that's pretty nice. The shop also says that it starts to surge and almost stall before it actually stalls. It always restarts right away, but when it restarts, he says it has a loud knock when it restarts. So that's what we're looking for. So the first thing I want to do is I want to get a scan tool on the car and get some basic data. So let's go ahead and get that scan tool installed. Okay, so I got the scan tool connected. I got the data up on the screen. We can see that we have RAF sensors. Centered means we have good control. The long term and total trim are good, they're green. Bank to bank is good. Time to engine temperature, we're 177, I just started it. The vacuum is good at 17 inches. Now I really like to see more than 18 inches on these Hondas. I'm a mile high, so at sea level, I would think any Honda would be making over 20 inches. When they don't make 18 inches, Hondas just have more vacuum than all the other cars I look at. Charging system is good. I don't have any codes and the monitors haven't been run. Now he told me that this car does not set codes for the stalling problem. There's no codes. But he unplugged some things and he had codes set, so he said he cleared what he set the codes. Apparently he set some codes. So the monitors haven't been run, and the mode 6 data also is not going to give me any data because they were just cleared. But they only set codes because he had unplugged some things trying to figure out what was wrong with the car. So that code being cleared, that doesn't really matter. The code doesn't set, even when the car is stalling, it doesn't set a code for the problem. So a scan tool just isn't really going to do me a lot of good right now. We want to come over here and we want to just look at our trims. So our trims are pretty good right now. These are pretty low trims. This was just within a couple of percent. So I really want to get a scope on this car, and I want to get the crank, the cam, an injector, and an ignition coil at least. And then I want the car to stall, and then I want to see which one of those went away, because one of those is going away in order to cause the car to stall. And if those don't go away, then I would be worried about the fuel supply system to the car. So really the first things I'm going to get into are the crank, the cam, an injector, and an ignition coil. So let's go ahead and get the scope set up on this vehicle. Okay guys, I found a wiring diagram for this vehicle, and I've got the cam and crank. So let me show you what we've got. The yellow channel 1 is on the crank. The red channel 2 is on the cam. The green channel 3 is on the injector for number 1. The white channel 5 is on the injector for number 3. Now he said in mode 6 when he checked this that 3 and 5 were showing misfires. So I want to have a couple of injectors at least just to see how they fail, if they're going to shut off or not. So that's sort of what I was thinking. Then I've got the ignition. I've got an eSCOPE on the coil for number 1. So that gives me all the pieces that I want to look at. Now let's go over to the scope and let's look at this. Okay, so we're connected on everything, and I've gone ahead and I've selected an amplifier for my eSCOPE and I zeroed it, so we're ready to go. So now we're collecting data. I wanted to do something else with the scan tool too. So I came over and I got the lambda from bank 1, lambda from bank 2, total trim bank 1, total trim bank 2, the RPM, the map, and the grams off the map, and the TPS. Since this is surging, I want to see what's making it surge, so this gives me my best chance to get that. Now we'll come back over here and we're collecting the data. Now we're waiting for it to stall or surge. He said it surges pretty bad, and he says it stalls. It mainly stalls once it gets hot, and it's only been running for maybe 10 minutes or so, so it's not quite there yet. So the green and white are the injectors, the blue is the ignition, and the yellow is the crank sensor, and behind it there's a cam. So we got a surge. So I want to go ahead and stop that. We'll come back and look at that. Let's look over here. So here's my data here. We can see that we went really rich right there. We went way rich, and we took away our fuel trims. So the fuel trims went away. So we did go rich, and we tried to trim for it. The RPM dropped, and then we opened the throttle position sensor to try to counter it. So that's all, I got that. Let's go look over here. Okay, so what I want to do is I want to look right here. This is where we've got some kind of a breakdown. Okay, we can see right here we have where it surged. I've got charging voltage at 14 volts, and I went to just battery voltage, so the charging system stopped charging when we had our problem. So let's go in and look at this real quick. We can see this is the cam, and this is the crank. These are the injectors up here. We can see the crank indexing marks. And the one thing that's really interesting is those injectors look really wide right there. Let's just see. See how narrow these injectors are right here? See how it went really wide? Okay, right here we surge. We can see it. So I'm going to stop it so we can come in and look at what happened here. Okay, so let's blow this up a little bit more. So we can see we have an indexing mark, and I've got an injector, but wow, look at how long that injector's on there. That's a long time that injector stayed on for. That injector came on for 10 milliseconds of time. So that's a big surge. Okay, so here we had a big surge here. We've got the cam and crank. So what I want to do now is I want to take a look at that cam and crank right where it surged there. I'm going to turn all this other stuff off for right now. Want to focus on, first we'll look at the cam, and we can see that we have three wide, 2 short, 3 wide. I don't see anything hanging down, or they all look okay. Now let's look, I want to do something else. Back over here. I want to look at this crank. We have a little bit of a hang down, but that's not low enough to catch a trigger point, I don't believe. So I'm not going to worry about that. But what I'm looking for is things like this that are bigger, where I might be able to recount an edge. We can see that this looks really clean. This is a pretty clean crank trigger as far as I can see. Back out. What I'm interested in is right over here before it did it. So here we are here. A little bit more zoom just so I can make sure I can see what's going on with this crank. Again, these are from the coils. Don't see anything in this crank trigger here. cam and crank signals, they look fine. They don't look like they've got anything that I can see where I would get some kind of a surge due to that signal. The signals right now, they look okay. We have more injector on time occurring right here, and we can just see the difference in how wide it is compared to over here before it surges. Now we just missed a surge. I don't want to miss this stalling, so let's get over here. So basically is what we're seeing is we've got the injector going on for a longer period of time and the engine is surging. We also saw that on the scan tool that went way rich and the fuel trim tried to take it away. But it's just trying to take away. Something's wrong here where we're getting too much fuel. I want to do one thing here really quick. I want to grab another channel and I want to get it into the map sensor. So I'm not in on 6 yet. Okay guys, this is the map signal now. So I've added a channel to map. Now what that's going to give me is if we had something change the load. What I'm worried about is the injection on time. The injection on time went way up. Now if the injection on time went on, you got to start asking yourself what would cause that. Well, if the load changed or the throttle position sensor thought it opened and the computer's reacting to that, it's going to make the injection on time come up. And that might give it a surge because we really didn't let any air in, but we gave it a lot more fuel. We could see the injectors went on longer, and we can see that the RAF sensor said it was rich. Now those two things tell me that why is the injector coming on longer? So now I want to get into the map just to see if I get any kind of a change. If anything let more air in, I would see it with a map change. That would change the vacuum. We're going to test it just to make sure I'm in the right wire because I just grabbed it. I think I'm in the right wire, but I'm not sure. Here we've got it rising where I snapped it, so we are in the right wire. So now let's go ahead and see what we get. That will give me an indication. That'll give me an indication if we had some type of an increase in load, because a load increase would give me too much injector. And we had another surge. I want to just take a really quick look. Now I don't want to miss when it stalls either. We can see again we drop from charging voltage to battery voltage, so the computer is shut off the charging system. We can see that we have an effect in the injectors and the ignition are both being affected here. Here we've got the cam signal, so we've got 2 shorts, 3 longs, 2 shorts, 3 longs. We've got our crank here. We can see that that's way longer on that injector right there during the surge. Do you see how long that's on compared to the rest of these? These two are on for a long time. This is very narrow right here. Let's just take a real quick look at this. Trying to figure out what's going on with the car. I can hear it surge. Now it hasn't stalled yet. Now right there we have 900 milliseconds of on time. So we went from we went from 2 milliseconds of on time to 9 milliseconds of on time. Now that's a huge difference right there, right? So once again, we can see that the injectors are clearly coming on for a longer period of time. When you look at it, you can see how wide that is and how wide that is, and these are narrow. So for some reason we're getting more fuel delivered. So the next thing that we need to see is what happened down here during our problem. So we can see that this opened. In other words, the throttle opened and I let more air in, but that's after my longer injection period. We'll mark this with the down cursors. So the down cursors are now going to mark where I just started to get a rise. Move back out. We can see those cursors right there. Now we can see that this right here is where we open those injectors up longer. This is where we got a rise. You can start to see this map rising. Well, the injectors opened first and I went way rich and the engine started to lose its RPM, and the computer commanded the throttle to open, and that let more air in to try to keep it from dying. The injectors are having the problem first. So the injector's having a problem and then I'm getting a rise. So let's go ahead and get this recording, so if we get a stall, we can see what's going on. Let's get that back. Now hopefully it just stalls. It's real intermittent, we know that, but now we know what's going on. The surge is caused by the injectors coming on for a longer period of time, very briefly, and I don't see that I had air going into the engine until after they started to flood the engine, and it stumbled and the computer opened the TPS up, allowing more air in. So we've been here for quite a while now, a couple of hours. We're just waiting for it to stall. I need it to stall. We keep seeing it surge, but I need this thing to actually stall so we can figure out what's wrong with it. Hey, it stalled, finally. Oh man, look at that. Look right here, the crank sensor elevated. Oh, that's great. Do you see how the crank sensor, it stopped pulling to ground? Okay, so the crank sensor failed. This didn't go to ground. The guys, the ground plane is down here. This is the ground, but it stopped pulling all the way to ground. Now the way that this looks, you can see the charging system lost again. I lost my charging. I was at charge. This is my battery voltage. It's almost like something's happening to the computer, like I'm losing my computer ground. But this is either the sensor or the computer ground. The computer sends a power and a ground to this. Is what I want to do is I want to come back over here and we want to look at the cam too. Let's make sure we didn't have some problem with it. Okay, now the cam continued to pull down to ground even though the crank didn't. Now these have a different ground going into the computer, but they might share a ground going out, but I don't know that. But the cam did good and the crank broke down. So clearly this is the crank failing. Either the crank sensor or a computer ground is causing a problem here. I went from basically 4 milliseconds and it went way up. Now, it went up a lot for not letting any air in. If I open the throttle and I get that kind of opening, it'll run. But if I didn't let air in, that's just going to be rich. And we can see that this one's even narrower over here. So, let's see where we're going from and to. So this is normal before it starts to go wider, and I have 2 milliseconds. So I've got a huge increase that's killing this engine. Now one thing I want to do is I want to start this car and I want to give it just a little bit of gas acceleration and see what's normal under a throttle acceleration where it sees the TPS move. Now that's just a real small acceleration right there. Now what I'm interested in is how far did these open? Now I accelerated and I let air in where I've got the right amount of fuel for the air opening the throttle blade. We'll have 14 milliseconds. And over here, I've got 8 milliseconds. So you can see that I'm getting as much fuel or more during these surges and stalls as I am during a throttle opening event. Now is what I'm going to need to do is I'm going to need to get into the ground and the power for the sensor, and we're going to need to see it fail one more time. Now I've been here for almost 2 hours to get this to fail. So it's hot right now, so I'm going to work really quick underneath there, and I'm going to get to the crank sensor and I'm going to get the power, ground, and signal at the sensor, and then we're going to watch it and we're going to see if we lose our ground or not down here. So, but that's what's going on, guys. Okay, so now let me move the leads because we're going to I need to put 2 more leads and I need to connect them to the power and ground at that crank sensor, but that crank sensor is definitely what caused the failure here. Now I've seen crank sensors where they're failing, and when they don't have a good pull down to ground, sometimes the transistor is failing and the transistor starts to fail on its cycles. So we can see right here, we can see that we got this is way away from this edge, and I think this should be really close to this edge. So if this starts to have the wrong pull down because the transistor isn't working, I could have a problem with my injectors in ignition as well. Now that I can clearly see that I have this problem with the crank, I'm not sure if that's the crank or the computer, but I know how to find it. So I'm going to move some leads real quick. And once I move the leads, we'll go ahead and we'll get it to stall again and we'll see what's happening. Okay guys, I got to the crank sensor and I got the signal. That's yellow is still the signal. And I've added the orange is my ground. That's what I'm really interested in. Does that rise up when I lost that signal? And this is the power that makes it work. Now if I lose the power, I'll lose the ability to make it pull down. So I got my powers and my grounds because both of those I have to have a good current path to make this pull down. So here we can see it pulling down. We can see the orange is my ground plane. That's for the crank, and the brown, let's get this back on so if it stalls again I don't want to miss it, because I saw last time it took me a long time to get this car to stall again. Okay guys, we're waiting for it to stall, but I went over and I changed something. I picked less PIDs. Less PIDs will give me a faster update rate. So I have the RPM, the throttle position, the map, and the mass air, and the calculated load. I'm trying to see if I can get any load to move, or the loads only move once I open the throttle position, like the RPM drops first and then the TP opens to try to save it from stalling. So this will give me a better idea. With less PIDs, it's going to be far more accurate. We had a surge right here, so let's go look at it. The RPM is the first thing falling. Then the throttle position opens, and then all the loads change after I change the throttle position. RPM's falling first, the throttle opens to try to counter it to keep it from dying, and then my loads are changing. I don't got a load before the RPM drops. So we're just sitting here waiting for this thing to die. We've been here for a few hours. The car just isn't cooperating with us at all. We can see it surge and it almost dies, but it just doesn't quite die. All right, guys, it died, yes. So let's take it out of fast capture. Okay, look at that. We've got the crank, it failed. We can see clearly where the crankshaft right here is pulled up. But this time we have more data. That's my ground from that sensor, and the sensor ground did not go up. The sensor ground stayed good. And this pulled up. So that tells me that this is the sensor circuit failing itself. Let's turn this stuff back on, go back out. What I want to do is I want to check something here. So now this is the cam, and this is the crank. What I'm interested in is I've got 2 narrow, 3 wide. I want to look at this front edge. So first off, let's get a time. So I'm going to go from a trigger, that's from an index to an index, that's 1 revolution. So I'm going to mark 360. Now it'll give me time. And now what I can do is we can come in here and I want to measure the difference. Right here. So I want to go from the falling edge to the falling edge. We have 6.1 degrees. Got 5.3 degrees. .2. So it's just moving around just a little bit. It's just bouncing. Now, is what I think, I don't think that this is moving around because of this has got a belt, and I don't think the belt is moving to make this move. I think these pull downs on the crank are failing. We know that the trigger has a problem because it's getting stuck high. I think something's wrong with the magnetic field going across the sensor with that sensor, and it's making it fail. These triggers are actually moving around. Here we've got 4.2. To realize I'm only checking one edge, but if all of these edges, if these edges on this crank are moving around and they're not pulling down properly to the trigger wheel, then the computer could get really confused and it might give me a problem like what I'm seeing with these injectors. Here we've got 4.2. .40. .40. 3.5. You know, if all these edges are just bouncing around 3 degrees, 4 degrees, it could really get the computer confused, because this runs off of an algorithm, and these algorithms are built, and they're built by the people that are programming it, and they never made the assumption that the trigger in the sensor could go bad and start pulling this at the wrong times. Here we've got 3.6. So if it's just bouncing around 3 or 4 degrees, that could be enough to give me the problem I'm having. The problem I'm having is very unusual. I've never seen this problem. It's really, really different. Here we've got 4.3. Let me go out. I want to show you something else here. Why is this so different? Now we can see the injectors, and we can see where they came on wide again, way long, and caused it to die. But notice how we've got three longs, and the first of the 3 wide, the white one is through it. First of the 3 wide, the white one is through it. In between the 2 shorts, the green one, or injector 1 happens, and injector 5 right here is going through this one. So what I want to show you is, notice how the white injector and the green, they stay in time. Well, in my experience and everything that I know, when I get a camera crank problem, these get out of order. Sometimes the ignition will, but almost always it affects the injectors, because these two build a model, and these edges are being counted in time to these edges, and it's trying to figure out where crank angle space, or what stroke I'm on of the engine. Now normally when I have a problem between these two, I get a problem to where these get out of order. Now you can see that they're staying in order. They're not getting out of order. They just go on longer. It's a very unusual problem. I just haven't seen this problem. It's very unusual. But I think the problem is the crank sensor is just got a different pull down. It's not pulling down right when the magnetic field goes through the Hall sensor, the MRE. I think this is a Hall. I don't think it's pulling down at the right time, so these edges are coming up and down at different times, and the computer is programmed for a certain outcome and it's not getting it. So we get the injectors that come on way wide because it thinks probably the engine is turning faster all of a sudden, and then we get wide injector on times, and then we create it to die. You can see how the crank is slowing down, and then this goes high. But the difference is this time I have the ground. So the ground is good. So this has to be in the circuit. This is the crank sensor itself. If this would have come up with it, that'd tell me that the sensor ground has a problem or the computer ground has a problem. The other thing we can see right here is where we had charge voltage at 14 volts, and then it falls to battery voltage. Now I think is what's happening right here is this a strategy. I think the computer sees it's dying and it wants to take the load off of the alternator to keep it from stalling. I think this is an anti-stall measure built into the computer is what's causing that right there. And the sensor power also has power, so we have a good power and we have a good ground on this thing. So basically we have a good current going to this sensor. The sensor is just clearly failing. Now you can see that this is a really crazy problem. As the crank trigger starts to slow down, then when it's going really slow, the crank trigger gets hung up about halfway. It no longer goes to ground, but the ground plane is staying good. So this is a really interesting problem. I've never quite seen the injector style problem. I've seen sensors do this, and on some of the sensors I've seen do this, I have really wild problems because they stop pulling these strikes. When these are being pulled down, when we come over here and we look at this 5 volts is being fed from the microprocessor through a resistor, and the sensor's job is to pull it to ground and release it. But if the sensor doesn't pull these down in the right times, and this timing of these edges gets out, it could get the computer confused. And like what we just measured is only one edge. But if we were looking at a bunch of these edges, we might see that it's bouncing all over and it's confusing the computer until we get long injection on times, too much fuel, and it kills the engine. Now, as the engine is dying and it's not rotating very fast, this is getting caught up. Now, I think this is just as simple as a bad crank sensor. So what we're going to need to do is the shop is going to need to put a new crank sensor in this vehicle, and then we'll come back. But he's going to need to put a crank sensor in, because I think that's what's wrong with it. I can clearly see the crank sensor is failing. Now, I've never seen anything with the injectors like this, but I think this has to do with just a bad crank sensor, and the crank sensor is not being pulled down in a timely manner what is programmed into this unit. Always remember that these programs, they have to match exact criteria in order for that program to run and make this engine run properly. And if these edges are getting off just a little bit and they're bouncing around, the computer can get confused with what it's doing, and then we could get these injectors on for a long time like this until it kills the motor. And as the motor starts to slow down and spin slower, I can see that the sensor's failed. I know that this is the sensor because our power for the sensor is good and the ground is good. So we have a good power and a good ground, and the ground definitely didn't pull up. If this ground pulled up, I'd need to be looking at what happened to the ground leg of the sensor or what is bad in the computer, because this wire goes back to the computer. And the other thing is, as we can see here at the end, the cam sensor stays pulling. It didn't get pulled up, but this guy gets pulled up. So I think this is just as simple as the crank sensor's bad. So this shop will put this crank sensor in, and then we'll come back and take a look at this vehicle. It died now, and we still have no codes. So let's read them. Like he said, the car stalls and it does not set codes. So the car still does not have codes, but it's stalled now. It's stalled twice, and we do not have a code for it. The thing the scan tool shows us is it does show that it went rich, and the fuel trims are trying to take care of it. Okay guys, I want to run one other test. I want to take a ground wire and I want to take away the crank signal. Now this car will run on the cam signal. So what I want to do is I want to take away the crank and I want to see if it still surges. I just haven't seen a problem like this. This is new to me, where I see the injectors go on longer but stay in order. They're not getting out of order, they're staying in order. Something I don't understand. But I want to take away the crank and see if it still surges or it dies. That'll tell me that it's something else, like it sees a load sensor changing and it gives too much fuel and it floods it. If the crank isn't there and it doesn't surge or die, then it's more to do with the crank. So let's go ahead and take care of that. Okay, so let's see if we can get this thing started. Okay, so we're running this off of the cam now, and it will crank and start with the cam, but it didn't like losing the crank. The crank made it flat die. So let's just see if we get any surging or it stalls without having the crank sensor there. I hate doing this because whenever you take a signal away, you could go into some kind of a default mode. I'm always scared, but on this car, this is something I've just never seen. This is a really different problem on this car. So I want to just take away the crank and I want to just see if I surge. The car doesn't die a lot, but it surges a lot. So if I get rid of the surge and it doesn't stall, well then I think the crank is causing it, because the only thing I took away is the crank. If somehow the computer is thinking the load increased, like the throttle opened and I'm increasing the injector on time, but I didn't let air in there, it would still do it even though I don't have a crank. The only way that taking away the crank would cure this problem if the crank somehow is interacting with this. And we can see that it's not surging at all right now. So let's just watch this for a little bit of time and see what happens. Okay guys, he's been here for a while now. So what I'm going to do is I'm going to give it back the crank signal. Now we let it run for 10 minutes, and with no surging, no dying, no anything, 10 minutes. It never surged or had a problem. As long as the crank sensor was gone, it cured the problem. Now the next thing I want to do is I want to go ahead and I want to take away the cam signal. So that's what we're going to do now. I want to get rid of that cam signal. So I've got rid of the cam signal. So let's go ahead and start this up and watch. But the cam signal is grounded. So if the car surges or dies, it doesn't have to do with an interaction between the cam and the crank. So there we got a start. It had a long start. Let me show you. We'll turn this off. See, there's no cam in the red. So we'll come back in and we'll start this again. Now, there's no cam, there's just a crank. So if it surges or dies, it doesn't have to do with an interaction between necessarily the cam and crank, but that would tell me that it's just the crank. When I took away the crank signal, I let this car run for a good 10-15 minutes. There was no surging, no stall, no nothing. And in that time, it definitely would have had a couple of surges. The surges are pretty frequent and pretty big. So now we don't have a cam sensor running. Let's see if it'll surge. Okay, there's a surge, guys. So we definitely had a surge. Right here's a surge. And we didn't have that when we lost the crank. When I took the crank away. With the cam away, we still surged here. You see we don't have a cam. We have the crank. And we can see where these injectors came on longer here. So we can definitely see where these guys came on longer and these are shorter. So we still have this injector going wider problem, but notice they're staying in time, they're not getting out. But we definitely have the same problem where we're surging still, but when we took away the crank, we did not have that problem. But when we take away the cam and we have the crank, we have the problem. Okay, so guys, I don't like taking away signals because I know I get burned like this, but I gotta think of some way to test this car because this is really a different kind of a problem. So if I take away the crank and it doesn't do it, and I take away the cam and it does do it, it's telling me the crank is still my problem. Somehow this crank is having an issue with its timing. I think the crank sensor has just failed. We could see it pull up and it didn't pull to ground. And later I'll explain in detail how these circuits work, how these crank sensors are in operation. But right now what I can see is if I take away the crank or the cam, I still have the problem. If I take away the crank and it runs on the cam, I don't have the problem anymore. Wow, look at that, guys. That was a big surge right there. Let's take a look at that guy. So again, I don't have the cam, but I got the crank, and we have a big surge. And we can see these injectors are on for a lot longer time still. Do you see how wide those injectors are on? See how narrow they are and how wide? I don't got to measure them. You can see it with your eye. I still have the same problem, but I don't have a cam sensor. I only have the crank sensor working, and I'm still having surging. Now to me, that's telling me that the crank sensor is my problem on this car. I can see the crank sensor failing. I can see it not pulling all the way to ground. It's already dying when that happens, and the crank starts to go really slow, and then that crank sensor gets stuck, and it gets stuck about halfway up. It won't go all the way back to ground. Now that shows me that the crank sensor has an issue. There again, guys, we have a pretty good surge again. We're only using the crank, not a cam. Had another surge. So that's just the crank doing this. Again, if I take away the crank, I never see this. I don't have the problem. It fixes the car basically. But when I take away the cam, I still have the problem. As long as the crank sensor's here, I have this very unusual problem where the injectors don't get out of sequence, but the injectors go on for too long a time. Now what I think is that the crank sensor is not being pulled to ground in a timely fashion. The magnetic intensity against the target wheel is off and it's moving around, and when it starts moving around, the computer gets confused, and here we got a surge again. That's what's causing the problem. So okay guys, let me unground. I want to give back that. We're going to give back the cam sensor. So now we have a cam sensor again. Here's where I turn the cam back on. So now we're running on a cam and a crank, both. And with both of them, we still have the same problem. The only way I cure this problem is if I get rid of the crank. And if I take away the crank and it still does it, I don't think that's a load sensor getting an increase somehow, or the computer gets, all of a sudden it thinks we're snapping the throttle and gives a bunch of fuel. I think that this problem has to do directly with the crank sensor. There it had a pretty good surge. We can see the surge right here. And again, we'll see that this is both sensors. But when I take away the crank, I don't have any problem with surging or stalling. So that pretty much in my mind is telling me that I have some failure in the crank. So what we're going to need to do is get a new crank sensor put in this car from the shop. Okay guys, check that out. I just turned it off because I'm going to leave. I've been here for hours. But look at that, when I shut it off and the crank starts going slow, do you see how the crank pulled up to half the distance? It's staying high. That's showing that the crank sensor is failing. But that orange right there is the ground for this sensor. So the sensor did not come up. The only thing that happened is I had a problem with the crank sensor that held that up. So it's like when the crank sensor or the crank starts to slow down and these targets are closer, then I pull up. This has something to do with how I'm shutting off, and the trigger wheel isn't moving as fast during this area, and you can see how it held up right there. Wow, that's pretty crazy. Okay guys, I just shut it off so we can leave, and I can see that I pulled the crank sensor all the way up. So the shop is going to need to put a new crank sensor in this car, and then we're going to come back and test it. So we're going to go, and then we'll come back and we'll let the shop get this crank sensor installed in this vehicle. And we'll see what happens. But the crank sensor is definitely having an issue. I believe that that's the problem with this vehicle. Okay guys, I'm back over here to look at this Honda. They put a new crank sensor, but the crank sensor did not come from Honda. This is factory back order from Honda. So he got a quality aftermarket sensor. He wanted one from Honda, but you can't get it because there's none in the nation. Tells me they're having a problem with these sensors. But he got a good quality when he put it in, and he says it dies worse now than with the other sensor. It's dying more often. He was saying you can barely back it around in here before it dies. So I got the scope connected, and now we want to see what we've got. So let's take a look at that scope. Okay guys, let's start this thing up and see what it does. Okay, start and stall. So let's look at what happened. Okay, that crank sensor pulled up again. Now the orange is my ground at the sensor. So let's take a look at this. This is the crank sensor. We can see we're toggling, and it clearly pulls to ground, and then it just stops pulling to ground. But that's after it started to slow down. It starts slowing down, and then when it's going really slow, this gets hung up and it will no longer return to ground. Okay guys, what I think now is this isn't the sensor. He put a new sensor in, and I know it's not a Honda one, but I don't care. It's not the sensor. Two sensors aren't going to do this. This has to do with the circuit inside the sensor is not being able to pull it all the way to ground. Now I think that has to do with the magnetic field interacting with the trigger wheel. So now is what I think is wrong, is the trigger wheel has become magnetized. I think the target wheel has become magnetized. And when two magnetic fields are working against each other, it's getting the computer confused by the edges. And I think it also has a problem to where when it goes really slow and it gets in the magnetic area, that magnetic gauss or the magnetic field stays on that sensor on the Hall or the MRE part of the sensor. I think this is a Hall. And then it's got so much magnetic field it can't fully release. So I think this problem now is in the target wheel, not the sensor. So what I got to do is I need to get this car up on a lift. So let me get a lift and get it up in the air, and let me get my Gauss meter out of my truck. I have a Gauss meter, and a Gauss meter will read magnetic intensity. So we can actually test the trigger wheel. So let me get this car up on a lift where I have access to the crank sensor because it's down underneath. So let me go ahead and get this car up on a lift, and then we'll see what it's doing with a Gauss meter. Okay guys, I got a lift and we got the car raised up, and I went out and I got my Gauss meter out of my vehicle. What's a Gauss meter? A Gauss meter is an instrument in which it will read the intensity of a magnetic field. Let me show you. This is the probe, and this probe basically has a Hall effector and MRE unit on it. And then when a magnetic field comes in, it changes the state of it, and it will give you the reading in Gauss right here where it shows 0. So the first thing I'm going to do is I'm going to take a real little magnet. This is a magnet that's pretty powerful. And I'm going to pass this by the probe. Do you see how it said It shows 42, 3, 94, 300. So that's really a strong magnet. So this is a pretty strong magnet, and it's a real magnet. Now, for this to read correctly, the field has to be perpendicular to the sensor. So if the field isn't perpendicular, it won't quite read it right, but it'll still get a reading. So no matter how the field is made, whether I come in straight, see I'm reading way less. And if I've got it to the side, I'll read way more. That's because that field is perpendicular to the sensor. But what I want to show you is it doesn't really matter. To read the right Gauss, it has to be perpendicular. But if it reads any magnetic field at all, there's a magnetic field there. So whether it's perpendicular or not, this sensor will read it. So we're going to be able to check that wheel to see if it's magnetic. Now I looked around and he had a drill bit, and a lot of times drill bits become magnetic from cutting. So he's got a drill bit here, and let me show you. Right here, this is a wire and a band. That's definitely got a magnetic field to it. Now we're going to read that field. Ten, 16, 7, 8, 16, 13. That's not a real strong magnet, but it definitely is magnetized. And we can see that it's magnetized for sure because it will do work for me. It'll pick up this wire. So it's definitely magnetized, and it's a magnet. And again, if we look at this, 17, 7, 6, 13, and if we come straight in, it's not going to have as big a reading because it really needs to be at a 90-degree pull to get it to read right. So again, this is a real light magnetic field, and I just wanted to find something that's not a real magnet, but something that's been lightly magnetized, because this is more like the trigger wheel is going to be. Again, you can see 9, 6, 14, 13, 15, it went up to 20. But we can clearly see that it's magnetized, and this Gauss meter is going to read that. So now what I want to do is to take this Gauss meter, and now I want to read that trigger wheel to see if that trigger wheel is magnetized. So the first thing we're going to do is what we need to do is to pull the sensor out of this engine where I can get access to the trigger wheel with my Gauss meter. So here's the crank sensor right here. I'm going to go ahead and pull this out so we can get access to that trigger wheel.
Recording.
Okay guys, we're going to rotate the motor while we're reading on the trigger wheel. Go ahead and rotate it. We went up to 11 Gauss. There's 3, 4, 5, 4. That trigger wheel's magnetized. 8, 9 right there. Go ahead and rotate it. Let's see what we got. 2, keep rotating it. 3, was definitely magnetized. Hit the button. Okay, go ahead. Rotate it. 13, 14, 15. Did you see it get to 15 there as he rotated it? Go ahead. 10, 2, 8, 10. That wheel is definitely magnetized, guys. Okay, rotate it. 3, 5, 12. 2, go ahead and rotate it. 12. Okay, that wheel is magnetic, guys, for sure. There's no question the wheel is magnetized. Okay, guys, we've just rotated this trigger wheel around, and you can clearly see that we're reading Gauss, or we're reading a magnetic field from that trigger wheel. That trigger wheel is magnetic for sure. Now, we've proven it now, beyond a shadow of a doubt, it is magnetic. Cool is that? Is that unbelievable? That trigger wheel has become magnetized. Now we know it's magnetic because the Gauss meter doesn't lie, and the Gauss meter is showing that the trigger wheel has definitely become magnetized. We just rotated the engine around and read the trigger wheel with the Gauss meter, and we can see that it's got magnetic now. Now when the sensor's magnet works against the magnet from the trigger wheel, it's going to offset, or it's going to move and change the timing, and the computer is trying to time those pulses, and when it can't do that correctly, the computer becomes confused and it's doing some really crazy things on this car. So in order to fix this car, we're going to have to degauss or demagnetize the trigger wheel. So I'm going to make a degaussing tool, and I'm going to have to come back and we're going to try to degauss that trigger wheel so we don't have to replace the motor. And I'm going to show you how to make the tool, and I'll show you how we're going to try to demagnetize it. Now I've never tried this before, so we'll have to just see how this is all going to work out. But in theory, I want to check the old sensor against the new sensor to see if the magnetic intensity is any different. So we're going to set we've got our 0. .318, 350, 323, 320, 380. Let's do the old one. 200, 268. The new magnet is way stronger, and that's what we would think. We would think the new sensor to have a new magnet, and it would be stronger. Now I think what happened is why we put the new sensor and it started to die more, is this is a stronger magnet, and then that magnetic field is interacting with the magnetic field on the trigger wheel. So it makes the problem worse, and the car actually got worse once we put the sensor in it. So that's why, and we can prove that the two magnetic fields are different. The old sensor isn't quite as powerful as the new one. So these Gauss meters, guys, it's just a great tool for checking magnetic intensity. Hey guys, how you doing? So we're back over at this little Honda Pilot. The shop has removed the oil pan where I have access to this trigger wheel. So what I want to show you is you can get an app on your phone that will do magnetic fields. So you can see it's metering up and it goes all the way in the red. But this is going to show me if I have a magnetic field or not and where it's strong. So now is what I want to do is take my phone and put it right up here by the trigger wheel. And you can definitely see that that trigger wheel is magnetized. Let's go ahead and rotate it. It's much easier once you have access to the trigger wheel. Before we had to go through the sensor hole. But you'll never degauss this wheel through that sensor hole. You're going to have to pull the pan and have access to it if we can even degauss it. We can definitely see that that wheel is magnetized. There's no question about that. Okay, so let's stop right there because that's a high reading right there. So let's just see what we got there. Go back. So now is what we want to do is I want to make sure that my degaussing. Let me show you my degaussing tool. Okay, guys, I got that drill bit that was magnetized over here. We can see that we got a real magnetic field there. We can clearly see it's magnetized. Now what I want to do is I want to take my step down transformer, and this is my degaussing tool, and we're going to take this drill bit, and is what's crazy, guys, is when I got this in front, this thing is vibrating. That I can feel that. You can see if I get it close, you can hear it vibrate. This is pulling the magnetic field and it's changing the directions. So what we want to do is we want to just go real slow on this. Now let's see what we did. And you can see this. You can see it reversing the field because it's reversing at 60 hertz. So clearly we've taken a lot of the magnetic field out. It's totally not gone, but we took a lot of it out of that bit. It still has some magnetism, but it's much, much better. Now what I don't know is I don't know how it's going to work on something big like this. I might have to have a more powerful step-down transformer or more winds on this. I just don't know. We've never done this before, so this is all experimental. So we can see where we have this right here. I marked the wheel where we had the highest magnetic field. So we definitely have a lot of magnetic field right there. So the first place I want to try to degauss is right there. So let's take our degaussing probe and let's go right into this area. Like I say, I don't know if we have enough power here to do it on a crank. We might need more power. I don't even know this can be done, guys. This is just an experiment. But it sure beats replacing the motor, pulling this crank to get that trigger wheel off where you can degauss it correctly. If this works, it's going to be a tremendous time saving and money saving. I'm going to slowly pull it back so we reduce the magnetic field slowly. That'll make those poles flip and stay flipped, hopefully. Let's see if we did anything. So it definitely is less. See how it's not getting in the yellow there? It's staying in the green, or it's staying in the green now. So that field is definitely reduced right there. Let's try to degauss it again. See what we got now. It's definitely lower than it was. There's no question that that's lower. Now, if we don't have enough in the end, we either make more wraps on my probe or I increase the current through this, means which I go to a higher step-down transformer. This is a 35 volt step-down transformer right now, but you can go to a 40 or 60 volt AC wave as well. So there's ways to make this more powerful. I just didn't know what it was going to take because I've never tried it. But it definitely is working. I mean, that definitely reduced that field. Okay guys, that's too cool. We definitely have taken a bunch of the magnetic field out of the trigger. So I just need to go around the whole wheel and we try to demagnetize, because some of that might be being picked up from the sides I have not degaussed. I need to degauss this whole wheel and then we need to test it again and see. The other thing that I need to go over is, how does this become magnetized? On all the magnetic shafts I've found, which is quite a few now, it's always a ground plane. So the starter has an inrush of 1500 amps to 2000 amps. If the ground is attached to the block or the head and not on the starter housing itself, the current path can start to go through the cams or the crank and you can magnetize them. So unfortunately, when I called the shop and I told them, I think I can deflux your crank, but the pan needs to be off, they pulled the pan. And so I didn't come over and voltage drop it, but he checked the ground because I asked him to do that. And the ground is not attached to the starter. And this is somebody's has rerun the grounds on this car. This is not a factory ground system from the battery to the starter. I think having the current path incorrectly connected to the engine from the starter to the battery allows that high current to go through the shaft and they become magnetized. Now in the past, when I found these magnetized shafts, you got to pull the shaft out and demagnetize it, and the easiest way to do that is find an airport around you, and there's what's called a magnifluxing machine. And that's where you make that, you put it in this machine, it's got two big ends, and they come in and it grabs your piece, and then you set how much current you want to go through it, 3,000, 4,000 amps, and you hit a switch and it puts it through, and that magnetizes the shaft. Then when you're done crack checking the thing, you put it back in the machine and you flip the current and it goes backwards, and it will demagnetize your shaft. So either you replace the shaft or you demagnetize it, and the best way to demagnetize a shaft once it's out is a magnifluxing machine. When I used to race off-road, I tore my whole car down every single race, and I would take it out to the airport and we would run all the parts in a magnifluxing machine. You would magnetize them and then you would demagnetize them. Anything that's non-magnetic, like aluminum, we would crack check with penetrating dies. But there's ways to find this kind of thing, and there's ways to demagnetize this, and the easiest way is a magniflux machine. But what we're trying today is to degauss this with a degaussing machine that I've made, and it appears to be working so far. Let me work around this crank and let me see if I can't demagnetize it, and then we'll recheck it. Okay guys, so what I first want to show you is we're right in the green and we're not even by a magnetic field. That's just the field we're getting. When it goes up, way up into the yellow, that shows we're magnetic. If we're down here in the green, we're good. So now is what I want to do, is we want to get up here and we want to see this. Okay, let's rotate it. Now this is the heaviest place. Before, this was going way up into the yellow. Now you can see that we're in the green and it's staying in the green. So we're going to roll it around, and if it starts to go up, we're going to degauss. This is what we've been doing. So we rotate it, and if it comes up into the yellow, we degauss it. And you can see it's staying in the green right now. It's not going up into the yellow, which says we've demagnetized that trigger wheel. I didn't think it was possible, but it actually degaussed it, so I'm really happy. Okay, let's do that right there. We can see it went up just a little bit right there. So I want to show you the technique so you guys will know it. You're going to take your probe, and what you want to do is you want to come in really close, and you want to go over the area you're trying to do, and slowly start pulling it back and keep moving it. that will keep those fields flipped. So that's what I've been doing, and it works really well. So I want to stay real close first, and then I want to start to slowly pull back to where I slowly reduce that alternating magnetic field on the wheel. So now let's check that and see what we got. Let's go ahead and roll it. Now before, when we were doing this, guys, it was going up halfway to 3/4 of the way through the yellow. Now we can see that it's staying down in the green, and it stays in the green when I'm not even by a magnet. Now you're going to have access to the wheel. You can't do this through a sensor hole, guys. You're going to have to be able to get to the wheel. So you're going to have to pull the pan or the valve cover or whatever trigger wheel, whether it's on a cam or a crank, but you need to be at the wheel in order to do this.
That needs to be done right there.
What's that?
It moved a little bit up.
Okay. We're going to degauss this a little bit again right here. Slowly just start pulling it back away from it. So we have a field, but the field is less intense. Now let's check this again. The phone app's really cool, but the phone app won't go through a sensor hole. And you really need to know that this is a problem before you tear it all apart. So to have the degaussing tool like I do with the probe that goes down through a sensor hole is really nice. So we degauss this area just a little bit more, guys. So now we're going to roll it, and we're going to see. You can see it's staying in the green. Before it jumped a little bit into the yellow right there. Now we got it down in the green. Okay, we're back around, guys. Okay, that's just incredible. I can't even believe it. We've actually taken the magnetic intensity out of the trigger wheel. So we'll put this car back together and we're going to test it. But we can clearly see that the magnetic field is out. Now before we do that, we're going to have to fix the ground on this or it's going to do this again. So let's take a look at that ground. So let me show you how shafts become magnetic. This isn't that common of a problem, but this is probably the 5th or 6th shaft that I've had that's magnetized. So this occurs. The problem is shops don't know how to diagnose it. They can't find the problem. So these cars go from shop to shop to shop until they go to the auction, and eventually they end up in a wrecking yard. These are really hard problems to solve. But what caused this in the beginning? Let me show you. Come here. Do you see how my battery cable goes to the ground? And then somebody has put a different cable on here, and it goes down around, and it goes to the head. It does not go to the starter housing. That ground needs to go to the starter housing, and it's going to the head. Okay, so let's think about this. So the inrush goes into the starter, 1500 amps to 2000 amps, and now it's got to find a way up to the head. Well, who knows exactly where my current path is? It's sort of like, do you know where lightning is going to strike? Not really. So that current path can take a different path than any of us would think. And in this car, I know where it went. It's going through the crank because we magnetized the crank and the trigger wheel. So that's clear where this current path went. But where that ground cable needs to be is on where the starter bolts go to the bell housing. I want that to be on the starter housing. Then the current goes through the starter, and it never goes into the engine and tries to find its way to a ground. It goes into the starter and goes right back to the battery, so you don't magnetize shafts. be careful with how you put your grounds. I mean, I know a lot of technicians, they just add a ground here or there and they put a cable somewhere, but you got to really think about what you're doing, because every time you put a new ground, you can change your current paths. And you don't really know where those current paths are going to do or what they're going to cause. I personally have fixed a lot of cars where people have added grounds and it changed the current path and it's tripping up the computer. So just be aware that that can happen. But on this car, before we crank this car over, he's going to put a new cable on here and he's going to put it to the bolt that holds the starter to the bell housing. That way the current will go right to the starter, through the starter, and come right back to the battery, where we're not going to remagnetize this crank now that we've demagnetized it. When he gets this car all put back together, we'll come over, we'll film it. I'll show you what goes on and how, or if it's fixed or it's not fixed, but it's not magnetic, so I'm pretty sure the car is going to be fixed. But we have to wait to see that until we got it running again, right? But he'll get it running and I'll be back over here once he gets it running and he gets this cable fixed. The one thing you do, if you degauss something, you've got to fix the reason that it got magnetic before you crank it, because it's going to flip those fields way easy. If that current goes through that crank again, or that trigger wheel, it's going to remagnetize it. So don't make that mistake. Make sure you fix the ground first, then crank it, start it, and see what goes on. We'll come back here shortly. Okay guys, we're back over at this little Honda Pilot. The shop has put it back together, put the oil pan and everything back on it. They've run this vehicle for over 3 hours. It is not surging, nor is it stalling. The shop is convinced it's fixed. So now is what I want to do, is get a fast capture of the cam and crank, which we've done. And now what we want to do is, I want to do what we were doing before, now that this isn't magnetic in its nature. We've demagnetized that trigger wheel, so let's just see what we get. We're going to mark index to index, mark 360, so it's marked. Now I want to come in over here and we want to measure these edges and look at what kind of change we have. 7.7 degrees. .8 degrees. .7 degrees. This is more how I would expect this to be. Not changing and not bouncing all over the place. .3 degrees. So we can clearly see, guys, we can clearly see the difference from before to now. It's pretty amazing. So now let's take a look at the battery cable. He's fixed the battery cable and he's done it proper now. So let's look at what they had and what he's got now. Okay guys, let me show you. The shop fixed the ground. Let me show you how it's properly done. We now have a ground that's to the chassis, comes down to the battery negative, and then we have a dedicated line that goes to the battery negative, that goes down, and it goes to the starter, and now he's got that cable that comes down and it goes to the bolt that holds that starter onto the bell housing. So the current will come right out of the starter and it'll go right to the battery, rather than before what was over at the head. Let me show you something else, guys. This is what he took off here. This is the cable that was on the car. This is the end that somebody had bolted to the head. Look at that. That's unacceptable, guys. That's what was bolted to the back head. This is what caused the whole problem on this car. Poor routing of a ground cable. Now I know when we put grounds on, a lot of us don't think about it, but remember that when you put the ground cables on, you can change the current paths. On older vehicles, it's not going to be so important because if I magnetize a shaft, there's no trigger wheels. There's not a cam trigger wheel, crank trigger wheels, but on these new cars, modern vehicles, how the current is going to come back to the battery and leave the battery is really, really important. So this is pretty funny what they did. So let's not do that. Be very aware to put the ground at the starter so the current doesn't go through the motor and then it can't magnetize anything. When I first became aware of these type of problems was way, way back when GM had the V8s and they had the shaft of the distributor was the magnet. And I had those shafts becoming demagnetized. And what was happening is it had a bad ground and the current was going through that shaft and it was demagnetizing the shafts for the distributor. So you can demagnetize something, but you can also magnetize something, as we've seen on this little Honda Pilot. This is more common than what we all think. These really happen. The problem is finding it. It's a really complicated troubleshoot to see what's going on, as we can see. But hopefully I've laid out a plan to where you guys could follow something like this and you too can now diagnose a vehicle like this. These are tough diagnoses. Okay guys, is that a crazy car or what? I work on nothing but crazy cars. All I work on is cars that can't be fixed, but that's one crazy Honda. It's one of my favorite cars that I've worked on in the last 5 or 10 years. I found a lot of magnetic shafts where the shafts and the triggers have become magnetized, but until now I've never tried to degauss one or demagnetize the shaft. I've diagnosed the car and they replaced the shaft or the engine, along with fixing the ground path before they do this again. But I've never tried to demagnetize one, so this is my first attempt to demagnetize a trigger wheel. Now at first I didn't think I could do it because that trigger wheel is a big piece and it's on the crank and the crank is magnetic. Now what I don't know is right now we've degaussed the trigger wheel and it's fixed. But does the magnetic field from that crank, where it's still attached to the trigger wheel, does it start to remagnetize the trigger wheel? That I won't know for a month or two. But I'll check back with this shop. This car came from another shop, so he'll have to get a hold of the shop and make sure the car's okay. I just don't know. I've never tried this before, but for right now, you can see we definitely degaussed it and the car is definitely repaired. It's a crazy repair. But this is the next level of diagnosing and repairing a car, as you can clearly see. If you want to get to the next level of diagnosing and repairing these modern vehicles, let Automotive Test Solutions help you, because we can definitely get you to the next level of diagnosing. Thank you for your time. Okay guys, I've been working on this degaussing tool now for a couple of days, and it is way more complicated than I would have ever believed to really degauss something. Now the first thing we all need to understand is you can't use DC current in order to demagnetize something. DC will magnetize it, AC will demagnetize it. So what we need is an alternating magnetic field that goes one way and then the other way and goes one way and then it goes the other, and it alternates. And what that does is a magnetic field is where the orbitals or the electrons are all orbiting in the same direction for a group of atoms. The more rotations that are in the same direction, the stronger the magnetic field is. So the idea of trying to degauss something is we're putting a magnetic field in one way and disrupting that orbit and then just flipping it back. And what we're trying to do is have those orbitals flip and stay flipped and not go back the way they were, and that will demagnetize it. In order to do that, we're going to use an AC step-down transformer. It's where we plug into the wall at 110 and the step-down transformer changes the voltage. This is a transformer that I ordered and it's 24 volt. I thought that might work. Now that I've been playing with it, 24 volts just isn't enough. So I went looking and I had a 12 volt power supply here, and this has a 35 volt step-down transformer. So this is what I'm going to use. It's going to work way better. So here's the scope. Here's my waveform. So here we can see we have a sine wave. So what I want to do is I want to go ahead and I want to take my cursors and I want to measure from halfway through the peak, and basically that's 49 volts. So now I want to take the 49 volts and I want to multiply it by 0.7, and that's going to be the AC voltage that we can use, or 34.3, 35 volt transformer is what this is. Now this is the voltage that we're pushing in and out of this winding. Is what I want to do now is I want to take a winding and I want to try to use that magnetic field. So this is a winding. Now when you wind the winding, they all have to be an air core. So that means you don't use a metal inside this core. Like if you use something like soft iron, it'll catch on fire or the winding can blow up, but you can be hurt by that. So whatever you do, do not put a steel or a soft iron core in this winding. That's a mistake. So I'm going to take these, I wound an air core. So now we can see that we're making a field, but the field's not very strong. See, it's not going up that high. So I have a wrench, and like many of you, if you have wrenches that are laying and you have these wrenches in the north-south magnetic orientation of the earth, they'll become magnetized. Now this wrench is magnetized. You can see it picks up that wire. Now I can take this and we can attempt to degauss it, but what I find is it really doesn't do anything. The other thing is this winding gets really hot. So it gets really hot. But you can see that magnetic field is still going all the way up into the red. And I can pick up this wire still, so I didn't demagnetize this. So I wound a few different windings, just experimenting, playing with this because I've never made one of these. So I took a whole spool of magnetic wire, and I wired it, so now the whole spool is going to become magnetic. I'm going to put that AC current through that whole winding. So we can see that again we have some magnetic field on the outside, but where it really is it's concentrating that field on the inside. So now I want to take my wrench and I want to try like this. Let's see if we... Okay, so I can't pick up that wire now. So I definitely changed the magnetic field. So we can see clearly that it doesn't go all the way into the red. Well, it hits the red some. So we demagnetized it some, but not enough. So we want to move this really slowly through this field. Let's see what we got. So we can definitely see that we've lowered that field. And it won't pick up the wire now, so we're changing it, but I'm still not degaussing this wrench. Now guys, if I can't degauss this wrench, there's no way I'm going to be able to degauss that trigger wheel. So I wound some of these, and I wound them bigger, thinking I might be able to make something that'd go around the trigger wheel towards the bottom, but the bigger I make this opening, the less intensity I have. So I got online, I read through all kinds of different information. Here's one article that I found, how to build a degausser to remove magnetism. Okay, so it sort of goes through it, but I want to show you something, and this is a reoccurring theme. Do not use a coil with a metal core. Now everything I can see says that this core will catch on fire or melt, and it's dangerous. So you got to be really careful when you have AC and it's going through this winding. So don't do that. Okay, so now I'm in an impasse. I don't know enough about this to get this job done. So now I'm wondering if I can even do it. But I have an ace in the hole. My business partner, Neil Peterson's father-in-law, is one of the leading physicists in the world. His name is Jim Potter. So I called Jim and I talked to Jim, and Jim says, oh no, Bernie, you're doing this all wrong. You got to put a metal core in there. I said, Jim, everywhere I've seen says do not put a metal core in it. He says, no, you got to use the right kind of metal. He says if you go to a electronic salvage yard, find a transformer out of the 70s or 80s, either a C or an E transformer, and take them apart and use that metal. He says that metal is very special metal, and it's not like normal metal. And he says it'll work great. So I went to the yard and we found some different transformers. This is an E transformer that I've taken apart. As you can see, this is laminated, and I broke this piece off. But this is what he's talking about. Now this metal is very different metal. Now this won't quite work, so I got another one, and this is a C transformer. You can see how it's like a C, and you can take this apart and we can use this. So I got another transformer, and I got this. Now if you look really closely, there's layers of metal. These are layered. This is laminated. And the lamination, each little piece, thin piece of steel, or not, this isn't steel, but this metal, doesn't touch each other. It's got like a varnish shellac around it, so they're not touching each other. Now the laminated layering helps with eddy currents, and it helps control heat, so it doesn't get so hot. It also helps reluctance and reactance of the magnetic field, so it moves through it easier. So now these are stacked, and you can see that these are layered. What I did is I put this in a vise and I whacked it with a hammer and I broke it in half. I took the other half, and these real sharp edges that are along here, I sanded those down so they're round, and then I ground one end down so I could get it in my chuck. And I got it in my chuck for my drill, so I could turn my drill, and then I can pull a wire, my magnetic coil, and I can wind it. Now you need hundreds of winds on here. You need between 200 and 400 winds on this. So that's what I did. So this is what I came up with. This is where I ground it, and I got that to where it'll fit in my drill. And I ground this down on the edges. Now the one thing is when you're putting that AC energy through this winding, that winding is going to start wanting to move from the magnetic energy in it. So you need to wrap the core in high temperature tape. Now I used, you can use a fiberglass tape, I use Mylar. Now you wrap the core in Mylar, and then you wrap the wire on the Mylar tape. So if it starts moving, it doesn't short to the core. When I was done, I wrapped the rest of it in Mylar tape, and then I soldered an end, and I did a twisted pair. The way you make a twisted pair is put this end in the vise, and then put this in your drill bit and pull it tight and spin it. And what that'll do is it'll eliminate getting a magnetic field in the lead. Then I just soldered on some ends. And now what I got, now I have something that makes a really good, strong magnetic field. The other thing is this doesn't get very hot. When I have my winding on this stick, this gets extremely hot in an air core. But when you have the right laminated material, you get amplification through the core, and every wind, for each wind, I have an amplification of 1, and then the core further amplifies it. So now we have a real strong, you can see it totally pegs out, but we have a really strong magnet now. Now with this, I can degauss my wrench. So I think with this, I'll be able to degauss. I think I can degauss the trigger wheel. Now, remember that there's 35 volts AC through here, so that could hit you pretty hard. So you might want to take your hybrid gloves, and hopefully you guys have hybrid gloves. They're rubber gloves for working on AC. You need to be really careful. Now I'm not worried about this on 35 volts, but I have a really talented electric tech here that works for ATS, and he knows what I'm trying to do, and he's been helping me. And he got online and he found something that I want to show you guys. This is a much, much better way to do all this. So this is what he found. This is a transformer, a step-down transformer. You're going to plug this into the wall, and then I'm going to be able to adjust how much voltage I'm going to push through the winding. Now the more voltage, the more current, and the magnetic intensity is proportional to the current you put through the winding at a 90-degree angle. So if I can push more voltage, I can make a much stronger demagnetizing tool. This also is fused, which means it's safer. So we can turn it on, we can adjust the voltage right here. It's fused, so it's less likely to hurt you. Now when I played around with this, I found that right at about 90 volts, my winding works way, way better. So this is what I think you guys should get if you're going to try to do this. Now this is the output. So what we did here is I just made a lead, and now this is going to feed my probe. Now if you're using this and we're pushing 100 volts AC, make sure you have rubber gloves, lineman gloves, because AC 100 volts can kill you. So be safe, use common sense. But this guy, this is really a trick way to do it, and it's going to get you more power. So now rather than pushing 35 volts through this, we're going to push 100 volts, 90 to 100, and it makes this field really, really strong. When we were measuring the amplitude and how much magnetism is coming out of this, I mean, from 35 to 90, that's basically 3 times, and it's got 3 times the demagnetizing power. So I really think that it's going to be better to use a device like that when you degauss your triggers. I'll put a link in this video to what kind of tool that is, but it's a great tool, and it gives you the adjustability of the voltage, so you can set whatever voltage you think you need. I know that we played around with this for half a day trying different voltages, and 90 volts in this coil worked really, really well. It's way, way stronger. So that's sort of what I got, guys. And I gotta thank Jim Potter, because without a guy like Jim Potter, this wouldn't have happened. I mean, I looked around online and nobody was saying to use an old transformer core. Now be really careful. Do not go wind a soft iron core. You can't do that when you have alternating current going through it. You need to use a laminated, very special type of metal that's in old transformers. Like he told me, find a transformer out of the 70s or 80s. In the 90s, they become switching transformers, and that's a totally different kind of transformer and a different metal. So get an old transformer, and you can take it apart, and then you can take the metal from that core, and you can break the lamination and just break a piece about what you want, and then wrap it, and you need between 200 and 400 windings to make it work. Make sure you wrap the bar in some kind of high temperature tape so the core can't short to this bar. It's really simple once you understand it, but until he explained that I could use this type of metal and I could put a core in, I wouldn't have been able to accomplish this. So really, it's great to have assets like Jim. Every now and then when I'm making something for ATS and I got some kind of question, to be able to call some of these people like Jim is just a great asset, and it helps us out immensely. Hopefully this helps you guys out if you're trying to degauss something.